Hi everybody, we are looking at a lesson from our current unit on equations and inequalities, and this in your packet is on page 3 in the packet. So we're just going to do a couple of examples together and then let you try some on your own. This is all about now how to write equations, when you might have situations where you write equations since we already know how to solve them by doing the same thing to both sides of the equation to get the variable by itself. So let's take a look at writing some. This opening exercise says your brother's going away to college, so you no longer have to share a bedroom. You decide to redecorate a wall by hanging 2 new posters on the wall. This wall is 14 feet wide, and each poster is 4 feet wide. And you want to place the posters on the wall so that the distance from each edge of the poster to the nearest edge of the wall is the same as the distance between the posters. So these 3 distances are all the same. So determine that distance. So first we're going to try this just if we gave you that as a story problem, just said figure it out on your own, any way you want to. And then let's look at it as how it would be with an equation. So if we were just going to figure this out on our own, let's see, what's the distance we're trying to find? We're trying to find these distances, and they're all the same, and we don't know them. So what can we call them? Let's call them x. So there's this x, this x, this x. If we were just going to do this any different method, I might say, well, if I've got 14 feet and I know I'm taking away this 4 feet and this 4 feet, I'm going to have some distance left, and I've got 3 of those distances. So maybe I'd just divide that by 3 to see. If I could do any method, I would probably start with the top, say, hey, I've got 14. I know I'm taking away 4 here and 4 here again for these guys. And so what's left is going to give me these 3. So whatever that is, I'm going to take that and divide it by 3 to see how long one of those distances is. So if I do 14 minus 4 minus another 4, that would be 10 minus 4 is going to be 6 divided by 3, and that gives me 2 feet. Now does that make sense if we go back and say, okay, well this is 2 feet plus 4 feet is 6 plus another 2 is going to be 8 plus another 4 is going to be 12 plus another 2 is going to be 14. So that makes sense to me. If we did this with an equation, we were calling these x's, let's use those variables. Here's our equation method. The equation method would just be saying, hey, what do all these things add up to? This plus this plus this plus this plus this equals 14. So I could either say x plus 4 plus x plus 4 plus x all has to equal 14, or I could combine my like terms and say, well, I've got 3 x's. Ooh, not 3 8s. 3 x's plus, and then 4 plus 4 is 8, and all that equals 14. So 3x plus 8 equals 14. That is an equation that we just practiced learning how to solve. So can you solve this algebraically? If you were writing an equation, you'd combine like terms, and then we'd be able to solve it. So I'm going to draw my line down my equal sign. What do I need to get rid of? First, the adding and subtracting. Let's undo that. We're going to undo adding by subtracting. Let's bring down what we have left. Plus 8 minus 8 goes bye-bye. And we have 3x equals 6. And here's where now we divide both sides to get rid of multiplying. We divide. So we're going to divide by 3. 3 divided by 3 is just 1. That goes away. See ya. And we get x equals 2. And it's still 2 feet. So different methods. This equation method really ends up doing the same things. You can even see the divided by 3 right there once we get 6. But this would be how we'd put it together algebraically. So let's look at another really similar situation. This one's got different numbers, and this one has some fractions in it. So this one, same idea. We're redecorating a room, and we want to find these equal distances between these points right here. So if these are equal distances, can we just call them all x again? And the same situation is going to apply. Let's look at, the only problem here is that the wall is measured in feet. It says it's 10 2/3 feet, which is probably more realistic than rooms being exactly 14 feet. There's probably going to be a fraction of a foot somewhere when you're really measuring. And then these posters, or these, I guess they're wall sconces in this one, these are in inches. So before we can go forward with this problem, we need to decide whether we're going to work in feet or whether we're going to work in inches. And let's try to write ourselves an equation for that. So what should we start with? Let's try feet first. Because we've got some fractions in there, let's try and say how many feet are each of these inches. 25 inches is how many feet? Well, let's kind of work with this. How many inches are in 1 foot? 12. So how many times does 12 go into 25? Essentially, I'm doing 25 divided by 12. So if I want 25 inches, and there's 12 inches in a foot, how many times does that go in there? It goes in twice with 1/12 left over. So each of these 25 inches are really 2 1/12 feet. Would you be able to write an equation in feet that would be able to solve this? Let's see what it would look like. We've got all of these things that add up to 10 2/3. So can we write it like that? We've got 3 x's. Can I just make it instead of x plus x plus x, say there's 3 x's? Plus there's 2 1/12 plus 2 1/12. So how many do I have? 2 plus 2 is 4, and 1/12 and 1/12 is 2/12. So I've got 4 and 2/12. Now, could I simplify that? 2/12 is the same thing as 1/6. So maybe I'll write 1/6 here. Say 3x plus 4 and 1/6. What do all those things added together give me a total of? What's this wall right here? 10 2/3. Is that an equation? Yeah. 3x plus 4 and 1/6 equals 10 2/3. Could we solve that? Well, let's try. Just because there's fractions doesn't mean we do anything any differently. Let's try and get rid of what we can get rid of. We're going to subtract first. We're going to undo our adding and subtracting. So we're really doing minus 4 and 1/6 off of each side. Because plus 4 and 1/6 minus 4 and 1/6 goes bye-bye. See ya. We're going to bring down, what we have left is our 3x equals, and then we do have to do a little bit of work. Let's just do the work off to the side for this so that we can get a final answer of 10 2/3 minus 4 and 1/6. I'm just going to do that down here. 10 2/3 minus 4 and 1/6. We've done a lot of fraction practice. In order to subtract fractions, we need common denominators. Can we make these thirds into sixths? What can we multiply both of these by? 2/3 would be the same as 4/6 if we multiply them both by 2. So this is really 10 4/6 minus 4 and 1/6. Well, we could turn these into improper fractions and subtract them, but since it gives us nice numbers, 4/6 minus 1/6 is just 3/6. 10 minus 4 is just 6. 10 minus 4 is 6, and 4/6 minus 1/6 is 3/6. So 3/6, what's another way to simplify that? That's going to be 1/2, 6 1/2. This just comes down to 6 1/2. That whole thing, all we did was just subtracted this guy to see that that was really 6 1/2. And then what we would do is we would divide on both sides by 3. And we'd get 6 1/2 divided by 3. Now, if we wanted to keep this as fractions, we absolutely could. But since 1/2 is such a nice fraction, could we turn that into a decimal? Can we just say that's 6.5? What would 6.5 divided by 3 be? No, it doesn't give us a nice one. Let's leave this as a fraction because it's not going to be very nice. Let's see. 6 1/2 divided by 3. Let's flip the second guy and multiply. This would be 6 1/2 times 1/3, and we need to make this 6 1/2 into an improper fraction. 6 times 2 is 12, plus 1 is 13 halves. Oops, not 13, 12, 13 halves times 1/3. Whew, what are we going to get for this? 13 times 1 and 2 times 3. 13 sixths. All right, I'd like to simplify that just so that I can see what does that mean. How many times does 6 go into 13? It goes in twice with 1/6 left. Whew. That was a good amount of work with fractions right there. Lots of fraction practice that we got. we get that x is 2 1/6. And what were our units here? This was all in feet. 2 1/6 feet. So does that make sense to us? If this is 2 1/6, it would be about 2 plus 2 plus 2 plus 2 plus 2 plus a little bit left over. 2, 4, 6, 8, 10 plus a little bit left over to get to our 2/3. That makes general sense to me. All right, could we also, if we wanted to, change that into inches? What if we didn't want to deal with all these fractions? What if we wanted to change our feet into inches and use these 25 inches here and 25 inches? Could we figure out how many inches are in 10 2/3 feet? Let's do that. Well, to figure out how many inches are in a foot, you multiply by 12. So if we're doing 10 2/3 times 12, 12 times that, we can do 12 times 10 and 12 times 2/3. We can put that together. What is 12 times 10? 12 times 10 is going to be 120. And then what's 12 times 2/3? 2/3 of 12. Well, a third of 12, 12 divided by 3 would be 4. So 2/3 of 12 would be 4 and 4, so that's going to be another 8. So it's 128 inches. Do you think that's going to make an easier equation to deal with if we just work in inches than when we were working in the fraction feet? Okay, let's find out. We're actually going to go on to the next page, and there's a place for us to do this. I'm going to flip over here. We actually already did this top part. That's what we were doing when we were finding the, oops, I'm crossing this off here. We did this top part. We were just doing that on the other page when we found the units in feet. Now let's do it in inches. They say this time to write an equation where y stands for the number of inches. So if we looked at the same picture on here, here's our picture. How would we write this? And we'll just call these y's right here with inches. So we have y, 3 y's plus 25 plus 25 is going to give us our total. So 3 y's plus 50 inches total. And that was going to equal our whole length of 128. So if we go back, we had 3 y's. So 3y plus, what did I say, 50 equals 128. That's a much nicer equation to deal with. Is this one going to be faster for us to solve? What would we do? Put our little line there, subtract 50 from each side, and then we're going to get 3y equals, and what is 128 minus 50, 78. To get rid of 3 times, divide both sides by 3, and you get, I don't have this one memorized. Sure, we could figure it out. 78 divided by 3 is going to be 26. So 26 inches for each of those in-between spots. All right. Let's just look at this last question related to this one. What values of y make this second equation true? Well, we just solved it. Right? We just went all the way down and solved it. Would 24 make that equation true? Would 24 work for this if we plugged it back in? No, neither would 25. The only thing that's going to work, the only thing that y can be is 26 inches. So that's the only one that would work for us. But it is worth looking at, what if we hadn't solved this equation? What if we hadn't done any of these and we were asked which one makes the equation true, 24, 25, or 26? What would our method have been? Well, take one of them, plug it in, and see if it's true. If we plugged in 24 for this, we'd be able to find out without doing the solving work at least whether 24 worked or not. If we plugged in 25, we'd be able to see whether 25 worked or not. Plugged in 26, we'd find out, yes, 26 definitely does work for this. 3 times 26 plus 50 is going to be 128. So there might be times where you just have an equation and you're not even asked to solve it. You're just asked which of these values makes it true, and you just need to plug it in. All right, so let's do one more type of problem today, and this is a problem where we are going to use our knowledge of tape diagrams to find out what to do. So this has a new vocab word for us. This is on page 5 now. The ages of 3 sisters are consecutive integers. This word consecutive means one right after another. One after another. So if 3 sisters had consecutive ages, it would be like one of them is 1, one of them is 2, one of them is 3, one right after another. This one, these are going to be older sisters because it says that the sum of their ages right here is 45. The sum means when you add up all of their ages. So sum, it means an addition problem. And we've got to find their ages. Well, I mean, we could probably do this by guessing and checking. Pick 3 numbers in a row, add them up, see if it's 45. Right? Let me show you another way where we can visualize this and then write a quick equation to be able to solve it. So if you picture, let's start with our youngest sister. We don't know how old they are, but the youngest one we're going to call X. So can you make a tape diagram for X? Remember how we just did our little piece of tape. The youngest was X. All right, now the next youngest is going to be whatever that sister is, plus how many? How many years older is the next one going to be? It's going to be 1 year older. So whatever X is, and we don't know that, it's going to be X plus 1 more year to make it a consecutive integer. So for example, if X was 1, then X plus 1 is going to be 2. She would be 1, she would be 2. If X was 20, she would be 20, she would be 21. And then the oldest sister is going to be what X was, but she's not 1 year older, she's 2 years older. So 1 and another 1. So we've got the youngest, 1 year older, 2 years older than that. So if we wanted to say all of these sisters added together, their sum is 45, can we write an equation now using x's and 1's for this? We've got x plus 1, 1, 1 has to equal 45. So how many x's do we have? We have 3 x's. And how many 1's do we have? 3. 3 x's plus 3 equals 45. So that's a good visual way of figuring out any problem that has to do with these consecutive numbers. You can visualize it using a tape diagram and keep adding to it for the next biggest number. So would we be able to solve an equation like this? Well, what would we do to both sides first? Undo the adding, subtracting. Minus 3 plus 3 minus 3 goes bye-bye. 3x equals, and 45 minus 3 is 42. And then we're just going to divide both sides by 3 to get rid of the 3 times. And you get x equals, what do we get? 14? Let's double check my math here. 42 divided by 3 is going to be 14. All right, so what did 14 stand for again? X was the age of the youngest. So if we need to find their ages, well, how old are all 3 of them? The youngest is 14. The next one must be 15. The next one must be 16. So that's the ages of all 3. Can we double check to make sure that's right? Is 14 plus 15 plus 16 equal to 45? There we go. All right. So looking at that, that's going to be a way for you guys to do any consecutive integer problem. This part B is literally what we just did there. Part A just said to draw a tape diagram, right? Part C is just giving an answer to that. So we did that whole page just in one problem right there. Okay, so you guys are going to do some practice. We're actually going to skip page 6 for now. I'm going to have you guys do the practice on page 7 for an assignment. So it really is only 3 problems that you're doing with some parts in between, but 3 main ideas. The first set says, check whether this given value is a solution to the equation. Well, here's this big, long equation. How would we check if n equals 2 works? Plug in 2 every time you see an n. So instead of n, use 2 and do the work over here and see if it works. See if it gives you a true statement. So you'll be giving me a yes or no answer with some work for that. This one also lets you check out whether something's a solution to an equation, gives you some practice at looking at writing an equation. And then number 3 is one where we're asking you guys to try a tape diagram problem, similar to what we did. Sum of 3 consecutive integers is 36. So you're going to draw me that tape diagram and go ahead and solve the equation, and then you'll be able to see if any of these work for it, but actually solve it. So we're going to say, write an equation that can be used to find the smallest integer and solve that equation. Show me the work for it. You can make that happen. All right. There is work paper if you don't have enough space on this page. There's work paper on page 9 for it. There is, I know there's a problem on page 8, but we're going to wait and do that one together next time. So just page 7 for you guys right now. All right, we'll see you later.